just not getting it, turn this over, back, okay? I want you to jot down the answers, but don't have it if it's visible, okay? I want you, because you will learn more if you do the questions, do the entire thing without looking at them, okay? And then you check your answers, okay? Very frequently, students get into the bad habit of trying a problem and then looking at the answer, trying a problem, looking at the answer. If you do that, your brain will be programmed to look for the answer right away, okay? If you're test or a quiz, you won't have that answer right away, so you'll struggle, okay? So jot down the answers on the back. Do not look until you finish the entire, all multiple choice. Does that make sense? Okay, and I won't be there to check you, but I promise you will learn more if you do that. Okay? If you do have the answers, go ahead and check your answers. And then I'll take questions about this, or any of the free response, or about anything else. You have questions on it before we take the chapter 13 quiz. By the way, if you're absent in class and you don't get additional problems that I hand out or a project, if it's a paper copy, then I will put it on the T drive. I will also usually put it on SharePoint and on the class website. I'll post most things in 3 places unless I miss, but I may miss one of them, but I post it in multiple places. If you're not here, you miss a day, look on the class website, on SharePoint, or on the T drive. It should be in one of those places. SharePoint should have opened up for students this week. Yes. Okay, number 7. A consumer product agency tests miles per gallon for a sample of automobiles using each of 4 different octanes of gasoline. Which of the following is true? A, there are 4 explanatory variables and 1 response variable. B, there's 1 explanatory variable with 4 levels of response. C, miles per gallon is the only explanatory variable, but there are 4 response variables corresponding to different octanes. D, there are 4 levels of a single explanatory variable. E, each explanatory level has an associated level of response. Okay, so there's a lot of intricate wording here, and a lot of them seem right. Okay, now we're using different types of 4 different octanes of gasoline, right? What is an explanatory variable? Have you used that word yet? Response variable. We've used response variable, right? Okay. You can think of response variable as a y value. Okay. Explanatory variable is like an x value, variable. Okay. And that's kind of my fault because we skipped over the first 2 units, and that was in the 2nd unit that we'll come back to at the end of the year. Okay. So an explanatory variable, right? That's funny. Okay. Explanatory variables you can leave as x, and a response variable as y. Now, if you think about gasoline as an x variable, okay, do you think that there are 4 different variables, or 1 variable that has 4 different levels? Okay, variable means that it would be different values, right? Okay, that's what I mean by in stats when we talk about variables, it means it has different levels. So it's not that there are 4 different variables, but there's a single y value, and that y value in this experiment has 4 different levels. Does that make sense? But there's a single variable, that variable is how much gasoline there is. There's just 4 levels to that variable. So D is the answer. Let's kind of go through these. You see, so it's not 4 different variables. B, there is 1 explanatory variable, Now, with 4 levels of response, make it seem like there are 4 different y values. And I don't know. That can kind of be justified because each explanatory variable, each level of x will have a level of y. It's like hitting more on some ideas that typically be skipped. So if that's why you're struggling with this, that's fine. I wouldn't stress about it right now. We'll come back to these ideas about 2 variables at the same time. Tell you what, let's just not worry about this one. Okay? Because it's kind of using the ideas from chapter 2, unit 2, that we've just skipped. We'll come back to later on in the year. So, sorry about that. That's why it was confusing. I was not worried about it. Y'all look like I'm crazy. So, let's move on. Other questions? No? Other questions? Things you guys are not sure why? Okay. So, is this an experiment or an observational study? Is there a treatment being imposed? Yes, what's the treatment being imposed? The food, right? So that you're imposing a treatment of giving this group hot oatmeal with fruit, and this group getting Western omelet with home fries. Okay, that's the treatment you're imposing. Is an experiment. Makes sense. Okay. Now let's kind of go through these. A, in general, people find Western omelets with home fries more satisfying for breakfast than hot oatmeal with fruit. Is that true? Why not? Okay. So you randomly split them up, you give them the food, and then you ask them for, they rate it on a scale of 1 to 10 for satisfaction. Okay. Western omelet with home fries received a substantially higher average score. So it was an experiment. I randomly separated them. They each had breakfast. They rated their breakfast, and the Western omelet with home fries received a higher average score, which does mean in general, people find Western omelets with home fries more satisfying than hot oatmeal with fruit. Okay, this is true because that's what the conclusion is from this experiment. Does that make sense? Okay. B. There is no reasonable conclusion because the subjects were volunteering rather than being randomly selected from the general population. Okay? Now, as far as I know, it's fine to use a group of volunteers because you can't really randomly pick people and then force them to do something. Okay? In the experiment, you're usually left to deal with volunteers. Okay? But you randomly allocate them. And so theoretically, the only difference between group A and group B is what treatment they're receiving. So I've randomly assigned them. Does that make sense? Okay, so theoretically, the only difference between group A and group B is what they're receiving for breakfast. Okay, so it's still fine that they are volunteers because they're being randomly separated into 2 groups. Does that make sense? Okay, so this is not the problem. C, there is no reasonable conclusion because of the small small size of the sample. Now, 25 volunteers per group, that seems like a good enough sample size to you? Okay, yeah, it is. It's depends on how accurate you want to be, but that's a decent enough sample size that you can get some good data from that. Okay, nod your head. Y'all look a little tired. D, there is no reasonable conclusion because blinding was not used. Now, could you use blinding in this?
to tell them about the other.
No, that's not what blinding is. Blinding is you know what group you're in. Is there any way you can sit down at your breakfast, have your meal given to you, and you not know what you're eating?
Or you don't have to.
You know what group you're in because you're eating either oatmeal and fruit or.
Or you don't have to tell them about the other group.
It's true. That they make a difference. They're saying this is an experiment. One group is getting oatmeal and fruit. One group is getting a delicious omelet with crispy French fries. And then you might be less satisfied with your oatmeal and your cold oatmeal and hot oatmeal and fruit. Because you really want the omelet, right? So I guess that may have a bearing. It's maybe less satisfied if you wanted an omelet and French fries. If you were in a diet, you probably would volunteer for an experiment with food. Anyway, so blinding isn't super possible here, but I do agree with the fact if you told them what the other group was getting, they may be jealous. Maybe you prefer oatmeal and fruit. Maybe you prefer an omelet with house fries. I prefer the omelet and house fries myself, but that's just me. Part 8. There is no reasonable conclusion because there are too many possible confounding variables, such as age, race, ethnic background of the individual volunteer and season when the study was performed. Is that true?
We have volunteers.
You have volunteers, and each person has a different age, race, ethnic background. Some people could just they love oatmeal and fruit. They have that every morning for breakfast. It's possible. Some people may have eggs and French fries every morning. Is this a problem?
Because it doesn't really pertain to what they're asking.
Do people with different, I'm not sure if age or, these kind of go together. Okay. Now, would your ethnic background affect what foods you like? Yes. If you were raised, it's true even in the States. If you're raised, West Coast or East Coast or, in the South or whatever, they'll have different food preferences, right? But that have a bearing on which one you prefer. Yeah. So, I'm saying that this isn't an issue. And I'm curious if you can figure out why this isn't an issue. Okay? We talk in your groups and try to just figure out why this is not an issue for our experiment. Ready? Go. Okay. How many of you have grandparents and you know what they have for breakfast? Do your grandparents eat oatmeal?
No.
Because mine did. Maybe they passed by that, but they have oatmeal? Yeah. I would say that oatmeal is more common amongst those that are older than those that are younger. How many of you have oatmeal? Oh, do you really? You guys come back. Yeah! Come back, oatmeal! Yeah. All right. Would age matter in this?
Yeah.
I don't think so.
They just ask them which of them.
Do you think age doesn't really matter? Like, in my thinking, like my grandparents all had oatmeal, and I didn't have. I had cold cereal growing up. Cereal, right? Anyway, okay. Do you think race, ethnic background would matter? What's that?
Well, there's only.
It depends on who the population is. If this is a nationwide restaurant chain, they'd want to know for the entire nation. If it's a restaurant chain that's only in this, there's one restaurant that's in the city of whatever, then that's who they want to focus on. That's the population. Okay? Now, the point I want to make is that age could make a difference. If your two groups were those under 30 and those over 30, and you gave them the meal, would that have a problem? Would that be a problem? Would it be a confounding variable? it would be what? Age. Okay? If you said all those who are American in this group, all those who are non-American from this group, okay, would that have a confounding variable? Yes. Okay. I'm not sure the season matters. I don't.
Well, they're hot.
I don't. Because they're both hot meals. If it's like cold cereal and like a hot omelet, that made different. They make a difference, right? In the winter, you may not want cold cereal or whatever. Anyway, so now the piece in here, and there's only one group that I heard was like kind of alluding to the idea of why these aren't an issue, why they're not confounding variables in this experiment, and it has to do with this. They were randomly split into two groups, right? So theoretically, all the age and the race, and ethnic background, all those individual biases for those individual people have been randomly allocated. So theoretically, there's the same kind of age distribution in both groups. There's the same ethnic distribution in both groups. Does that make sense? So according to that random allocation, those all should be worked out. There should be no confounding variable because of the randomness. Does that make sense? Okay, so this is not the answer either. And the answer is A.
If it's randomly split, there's never going to be like confounding variables.
Theoretically, no. I mean, it depends on if how prevalent those variables are, and I mean, in this case, I think we see that these biases may not have a huge impact on what we're doing. If you're doing a study where there's a large group that would have, a large bias, then it may make a difference. But in theory, the random allocation eliminates these biases. Okay, so this question, I'm sorry, I thought I should have been more thorough with these before. We've been talking about matched pair experiments. We'll cover that probably like next year, like January, February, March time frame. Okay, let me tell you because it's good enough. Most of our experiments we've talked about so far is you take a large group of volunteers, like the food we were just talking about, right? You split them into two different groups, right? You give each a treatment, and you see the response from those treatments. Okay, that's a very basic experiment style. Okay, sometimes you want to measure people before and after the same person, right? So, for example, if you're doing a diet, you can measure everyone before, put everyone on the same diet, and measure the results at the end. Does that make sense? And what you're comparing, your control group, is the before weight or health level or whatever you're setting. Okay? The before is the control group. That's the status quo, right? And then you're comparing that to the after. Make sense? Okay? So that's the idea of a matched pair. You're measuring the same person just before and after something. Because you're pairing those data together. Okay, so it's a different. We do different calculations with that. We'll talk about that later on in the year. So, sorry about that. I skipped that. So, yeah, that's all I'll say about that. Yeah. So you can skip this one too. Because we'll talk about these ideas later on in the year. I'm not worried about that right now. So sorry about that. The big differences between lurking and confounding variables. So a lurking variable is a variable that affects both the explanatory variable and the response variable. And it makes it seem like one is causing the other, in a lurking variable. Okay? A confounding variable is in an experiment if there's like more than one change happening. Is the most common case that I can think of. You can't tell the difference between the two. Like when you write something down. Okay. So lurking is where there's some other variable that's affecting both x and y and making it seem like this is the case. And x is causing y. Okay? Confounding is where in an experiment so here's your group. You randomly break them up into two groups. This group gets these three things. This group gets these different three things. Well, we do this way instead. This group gets A, B, and C. This group gets D, E, and F. Okay, and then you compare the group. Okay. Whoa. Whoa. Come on. Okay, you compare. Now let's say that this group was significantly better. Okay. Now, is it a result of A, B, or C? Well, if it's all together, yeah, it's better, right? But the reason why it's better is it because of A or B or C? The answer is I don't know. Okay. These variables are confounding. Okay. I can't separate them because my data has all of them, right? That's the idea of a confounding variable. Okay, where I can't separate the levels of them because they're all combined, and so I can't tell. Okay, it's like the last class about a coach, right? A coach comes in, has different, different practices. Is the practices or the new coach? We don't know. We can't separate those two things. They're both in there, right? That's a confounding variable.
Do you have to be testing really multiple variables at the same time? Could you be testing one variable, but after you reject it, you realize that it works?
You can be testing one variable. Yeah. I'm guessing that what usually happens is you're testing one variable. These are treatments, right? Treatments. Where you could be, only imposing one treatment with one variable. But after you find that group A, that this group it was a lot better or a lot higher or lower or whatever, and then you realize that group was made entirely of males or females, or that there was a huge discrepancy between males, females, or race or whatever. Like you realize that there's a huge difference, even though it was randomly assigned. There could be a huge difference, and that difference could be making an effect on your study. So it could. But the simplest case is where multiple things are happening and you can't separate them. Any last questions? Going once, going twice. Sold. Okay, I've given you each two papers, right? My hope was to get done the part 3 free response practice. To get it done in class. Do 15 minutes. Don't get through all of it. Okay, we do one problem. And the other thing is a practice test. So there are 20 multiple choice questions along with 3 free response. Your test next class will have, yeah, 20 multiple choice and 3 free response. Different than the practice test. Okay, but so you're used to taking that kind of a test. By the way, there's the answers for this practice test are online, and a second exam, and those answers are also online. So there's plenty of things you can be looking over as you're studying. Yes,
So they have a whole class
the test is 90 minutes long, yes. Okay, so what I would do if I were you is I would take my practice test, I would give myself 90 minutes, and whenever I got done, I got done. And then I would check if my answers online with those answers. That's what I would first do. What? That and the answers, and another practice test, and those answers are also online.
Is this going to be over 3?
What's that?
Free response.
That isn't yet online, but I will put it online.
Is this one?
Yes, I do want you to finish that. Okay? Now, let me warn you. Okay? Usually students struggle more with the free response than they do with multiple choice. You're very good at taking multiple choice tests. If you weren't good at that, you wouldn't be an AP. Let's be honest, okay? Students struggle more with free response than they do with multiple choice. I'm not concerned about multiple choice. That'll take care of itself. Okay? The free response is where I'm concerned. Okay? We have a little over 10 minutes left. I want you to do the very first free response on the part 3 free response with like 13 rectangles. See that problem? Okay? Will you just do that problem right now? And then we'll talk about it in about 10 minutes. Okay, ready? Go. Okay, real quick, we have 2 minutes left. For part A, you should talk about kind of explaining how you went about describing which of the floors, that you do 2 floors, do all the apartments on those floors, right? Okay. The other way is you can stratify based on children. So it says give one reason for selecting a stratified sample as opposed to a cluster sample of 8 apartments using the floors as clusters. Okay. You should probably talk about the fact that with children they may have different types of wear on the carpet than without children. Okay. That's basically it for that first one. That makes sense? Anything how to do those? Okay. I want you to finish these free response and do the other first practice test, and including those 3 free response in the practice test as well. Okay. Pay attention to those. I'm more concerned about free response than about multiple choice because usually students are fine with multiple choice. It's free response that make or break you. Okay. Any questions?